we're going to do a quick review of those different kinds of reactions. A lot of us in class were talking about being confused. It's a lot of information. So we're going to go ahead and just go through these reactions one more time. So there are 5 kinds of reactions, and it says 6. There are 5 main types, and then this 6th guy is actually a special kind of double replacement. So synthesis, decomposition, combustion, single replacement, double replacement, and then acid-base reactions are one special kind of double replacement reactions. We're going to look at all of those guys. So in a synthesis reaction, literally things are being synthesized. We're taking little pieces, 2 or more little pieces. We're combining them together to make one big product. So in a synthesis reaction, you're looking for just one product, one thing on the right side of the yield sign. For example, this one, I've got potassium and chlorine. I've got 2 things in the reactants, only one product. These 2 guys are also synthesis reactions. I can combine copper and sulfur to make copper sulfide, but wait, because copper is a transition metal, we could have copper 2 sulfide, like this. We could also have copper 1 sulfide that looks like this. But both of these are synthesis reactions. I have multiple reactants, one product, one product. Synthesis reactions, one product. Decomposition reactions are the opposite. We have one reactant that breaks down into multiple pieces. We have water being broken down into hydrogen gas and oxygen gas. Calcium carbonate, this guy can break down into calcium oxide and carbon dioxide. We have one reactant, multiple products. A single compound, one reactant, broken down into many products. Combustion reactions. Something reacts with oxygen. So you're going to look for O2 in the reactants. You're going to have O2 in the reactants. Often, this combustion reaction, this is stuff burning. We have heat or light. Some kind of energy is usually produced also. So in this one, I've got methane reacting with oxygen gas to produce carbon dioxide and water. If you have a hydrocarbon, hydrocarbons, you can probably guess, are composed of only hydrogen and carbon. Hydrogen and carbon. When hydrocarbons combust with oxygen, it has to be oxygen. If it's not oxygen, it's not combustion. When hydrocarbons combust, products are going to be CO2 and H2O. You should memorize that. So memorize that if you've got something that's only C's and H's, any number of C's and H's plus O2, the products are going to be CO2 and H2O. Carbon dioxide and water is the product of combustion of hydrocarbons. This is not a hydrocarbon. In its combustion, we are not going to make carbon dioxide and water. There's no carbon. There's no way to make carbon dioxide. There's no hydrogen. There's no way to make water. This guy is actually going to rust. It's combustion, but for us, we're going to talk about these metals kind of rusting when they combine with oxygen. So we're going to make magnesium oxide. What's interesting about this reaction is it is combustion because of that oxygen gas here, but also because I have a single product, this is also a synthesis reaction. This is one of our examples of multiple types of, multiple categories. One reaction, many kinds. It is both combustion because of this O2 gas. It is also synthesis because I have one product. The magnesium and oxygen combined to synthesize magnesium oxide. All right, replacement reactions. Literally, elements are kicking each other out of compounds and taking their places. That's why it's called replacement. In single replacement, there's some single element in the beginning that knocks something else off, and then the other thing is single. So I have potassium single, now I have hydrogen single. I think this is easier to see if we think of H2O as in its molecular structure. So H2O looks like this, right? So this potassium comes in, knocks out this hydrogen. He is now over here by himself. That potassium then takes the place of the hydrogen. It replaces hydrogen on that leftover OH. That's the KOH that's here. And then the hydrogen that we kicked off finds another hydrogen and makes hydrogen gas. Remember that hydrogen is diatomic. Hydrogen gas is always going to be H2. This one, same idea. This magnesium is going to come in. He's going to knock zinc off of the nitrate. Magnesium is going to replace the zinc. So now instead of having zinc on nitrate, we're going to have magnesium on nitrate. Remember that magnesium has a +2 charge when it's in a compound. Nitrate is a -1 charge, so I need 2 nitrates to balance out the +2 of the magnesium. When magnesium knocks zinc off of nitrate, we now have zinc metal by itself. So this is single replacement. Magnesium used to be single, now zinc is single. Zinc used to be on nitrate, magnesium replaced the zinc, now magnesium is on the nitrate. Single replacement. Similar to double replacement, but now there's nothing single. Everything is starting in a compound. So I have a compound, a compound, a compound, a compound. No single elements here. What's going to happen? The sodium that's on the sulfur is going to replace cadmium on the nitrate. So I used to have sodium on sulfur and cadmium on nitrate, but now we're going to put the sodium with the nitrate, sodium with the nitrate. And instead of the sodium being on the sulfur and the cadmium being on the nitrate, the cadmium is going to trade places with the sodium. The cadmium is going to be on the sulfur. The cadmium is going to be on the sulfur. So these two guys, these two metals, the sodium and the cadmium, simply trade places. There's nothing single, there are no single elements in here. Instead, I've got these two metals trading places. Sodium used to be on sulfur, now sodium's on nitrate. Cadmium used to be on nitrate, now cadmium's on sulfur. Same thing here, we're going to trade our two metals. So potassium and barium are just going to trade places. We used to have potassium on carbonate, now we're going to put the barium on the carbonate. Barium on the carbonate. And we used to have barium on the chloride, now we're going to put the potassium on the chloride. The potassium on the chloride. Potassium on the chloride. Since it's ionic, we've got to check our charges. Barium's a +2, carbonate's a -2. We're golden. We don't have to do anything to balance those out. Potassium's a +1, chlorine's a -1. We don't have to balance anything out. We do have to throw in a coefficient to balance the whole equation. So I've got 2 potassiums and 2 chlorines. We're just going to put a 2 in front of potassium chloride. So there are some kinds of double replacement reactions that are specifically acid-base reactions. Not all double replacement reactions are acid-base. It's kind of like dogs and mammals, right? So all dogs are mammals, but not all mammals are dogs. All acid-base reactions are double replacement reactions, but not all double replacement reactions are acid-base reactions. So anyhow, acid-base reactions, one special kind of double replacement reaction. We're going to produce water and some kind of salt. A lot of times we talk about salt as being NaCl, but in reality, ionic compounds that can crystallize, these are all considered salts. So what happens is this. Our acid is going to start with an H. We know it's an acid, it starts with an H. Our bases, we're looking for this hydroxide group. This base is going to have this OH minus hydroxide ion. What happens is this OH and this H, they are going to combine. So instead of having H on Cl, we're going to put the H on the OH. HOH is the same thing as H2O. And then the sodium that used to be on the OH is now going to go onto the Cl, and we have NaCl. This is our salt, and this is our water. Same thing's going to happen here. The H on the acid is going to trade places with the potassium that's on the hydroxide group. So instead of H on Br, we're going to put H on OH. H on OH, that's the same thing as H2O. We've got our water. And then the potassium that used to be on the hydroxide, the OH group, that potassium is now going to shift over to the Br, the bromine. So instead of hydrogen on bromine, we're going to have potassium on bromine. We're going to have potassium on bromine. This is a kind of salt. It's an ionic compound that crystallizes. And this is our water, salt and water. So here, let's do a quick review. Lots of different kinds of things all at once. Some people like these pictures, some people don't. So you can think about synthesis reaction as being multiple pieces combining to make one product. Decomposition is the opposite. We have one reactant breaking down into lots of products. In combustion, we're looking for O2 gas in the reactants. Single replacement, we used to have a single element. It is now in a compound, and a different element is now single. Double replacement, these guys, you're looking for the longest equations. So if you have compound, 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 more compounds, if there are a lot of elements, probably, most of the time, it's going to be a double replacement reaction. Where A used to be on B, now A is on D, and C used to be on D, now C is on B. A and C simply traded places. So let's look at these reactions and see if we can match them to their type. I have compound, 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 compound. It looks like this might be acid-base because I made salt and water, but friends, this is not actually a base. So this one is simply double replacement. The sodium that used to be on the oxygen is now on the chlorine. The sodium's on the chlorine. And the hydrogen that used to be on the chlorine is now on the oxygen. Double replacement. Let's look at this guy. I've got two reactants, a single product. Single product tells me that I've got a synthesis reaction. This one is a synthesis reaction. Single product. This is the opposite. I've got a single reactant, many products. This is going to be decomposition. This one reactant is breaking down into multiple products. Hey, look what I've got here. Oxygen gas in the reactants. That makes it combustion. And this guy, I've got single sodium, and now I've got single hydrogen. The hydrogen that used to be on the chlorine is now by itself. The sodium that used to be by itself is now on the chlorine. That's going to make this single replacement. Single replacement. Let's practice just a little bit more. I've got, oh my gosh, look at all those letters. It's probably double replacement, but let's check to make sure. I've got lead on nitrate. I've got potassium on chromate. Oh, hey, now I've got lead on chromate and potassium on nitrate. The lead that used to be on the nitrate is now on the chromate. Potassium that used to be on the chromate is now on the nitrate. This is definitely double replacement. I have a single element and a compound, and now I have this different single element. The potassium that used to be on the iodine is now on the chlorine. These guys traded places. Since I have a single element and a different single element, this is single replacement. Lo and behold, I've got oxygen gas in the reactant. That makes it combustion. Here I've got one single reactant breaking down into multiple products. That makes this decomposition. I've got multiple reactants. Single product, one single product. That's going to make this synthesis. But wait, look, there's also oxygen gas in the reactants. That makes this not just synthesis, but also combustion. How about here? I've got HCl and FeO. Ooh, I've got an acid. Does that make this acid base? It doesn't. This isn't a base. So this is simply double replacement. Used to have hydrogen on the chlorine. Now we have iron on the chlorine. We used to have iron on oxygen. Now we have hydrogen on oxygen. This is double replacement. I've got a single reactant breaking down into multiple pieces. That makes this decomposition. And here I've got calcium on cyanide, and now I've got calcium on sulfate. I've got hydrogen on sulfate. Now I've got hydrogen on cyanide. That makes this one double replacement. Hopefully this review was a help to kind of put better into your brains all those words from class. If you have questions, you know where to find me.